This conference will now be recorded.
Okay, so today we'll see about table spaces. What are table spaces? Why should you go for it? How to create it? What is the advantage of it? So how it is different from data files, all those things we'll see now. Okay, so table spaces. I'll share my screen. So table spaces are logical structures. Okay, logical structures means in OS level you can't see it. So table spaces are logical containers, you can think, or logical structures which hold the data files. Okay, which hold data files. So data files are the physical structures. Data files are the physical structures. So data files we know which are logical structures in OS level, we can go and see. So we'll see now. So an Oracle database is comprised of table spaces. Okay, they are logically organized or logical containers or logical structures we used to say, but the data are physically stored in data files. Okay, so like this we'll see. See, we have the table space like this. We have the data files here. Okay, a single table space, which is a logical structure, contains the physical structure called data files. Here these are the data files, which are the physical structures. Okay, so we have the objects like tables, indexes, or clusters, or synonyms. Any object can be stored. There is misconception that only table space means space only for tables, like that. Not like that. So we can store all the objects as well here. Okay, as tables, all the objects we can store inside our data files. So data files are in turn inside our table spaces, right? Here table spaces are logical structures, as well as these objects are logical structures as well. So we cannot go and check in the OS level these objects. Fine. So these data files are stored in the OS level. Now this table space, we can say that 2 data files it contains. Okay, so we can check here, that is these are the data files and these are the objects, but the data files can be within that particular table space. Similarly, our objects can span between the data files. So while we are creating the table space and the data files, we don't know where the objects will be stored. It depends on the Oracle's internal algorithm. In which data file which objects are stored, we won't be knowing. Fine. So but we know that object belongs to this particular table space, that's it. But this table space might contain 5 data files or 10 data files, so we won't be knowing where these objects are getting stored. Fine. So this is what is the table space, the definition of table space. Fine. So now we'll see what are the types of the table space. So types, we have one is permanent table space, second one is undo, third one is temporary. Okay, permanent, undo, and temporary, right? So this permanent, we can classify it into two types. So one is system defined, another one is non-system or user defined. Okay. So now system defined means what? System defined means the table spaces defined by the system, that is created by the system while we are creating the database using our DBCA. Okay, the system will be creating these table spaces. So what these table spaces are means system table space and sysox table space. Okay, system table space and sysox table space, these two are the system defined table spaces. Whereas non-system table spaces means so this undo and temporary as well will come under the system defined, because system only will create the undo and temporary apart from the user defined table spaces. Okay, so user defined means we used to create for our own data. We are creating for example HR database I am running or inventory database I have. So all the user defined objects, my application data I want to store in my own table space means I call that as the non-system or user defined table space. Fine. So next one is undo table space. So this undo table space contains the uncommitted transactions. Okay, uncommitted transactions. These undo table spaces are present. Fine. So next one is temporary. So temporary means what? All your sorting and searching are done here. Okay, sorting and searching are done in temporary table space. So this is how it is organized. Okay, so permanent means it contains two types. One is system defined, the other one is non-system or user defined. So system defined means you have the system and sysox, whereas user defined means what the user is creating and storing their own objects. Uncommitted transactions will go and store under undo table space, and temporary is for sorting and searching purpose we are using. So the system table space contains what? So it contains data dictionary objects. Okay, data dictionary objects. So data dictionary objects means what? Metadata. Okay, metadata of the database is kept here, of the DB is kept under system table space. And how about sysox table space? So sysox table space, we can we have the wizards, no, like netCA or DBCA. Using DBCA we create the database. DBUA, okay, to upgrade database upgrade assistant. netCA means net configuration assistant, database configuration assistant. So all these wizards are kept under this sysox table space. Other than that, using a log miner utilities. Okay, so Oracle streams, all those Oracle streams for all those objects are kept under sysox table space only. Fine. So this is how it has been organized. Now see, a table space contains how it is divided, how it is organized means, see for example, we have one table space. Okay, so we have inside this table space are being organized very well with like these lines. We can draw some lines. Okay, so here table spaces are divided into so many segments. Okay, segments, and each segment is divided into extents. Okay, and each extent is divided into blocks, right? So one tablespace contains many segments. One segment contains a couple of extents. One extent contains couple of blocks, right? So this is how it has been organized. Let's see. See, this is the tablespace. So this is the tablespace. Okay, and the whole thing is tablespace, and this is segment. Each one is segment. Okay, so now each segment is again classified into so many extents. Okay, so see like this. Like this, each segment is classified into so many extents. Okay, so extents. Each extent again is classified into so many blocks. Okay, blocks are the basic storage unit of the table spaces. Okay, so this one is blocks. So this is how it is organized. So the whole table space, one database consists of so many table spaces. One table space contains, whole table space contains number of segments, and each segment is classified into number of extents, and each extent is classified into number of blocks. Okay, so this is how it is organized. Now see, table space types we have seen, that is permanent, undo, temporary, and permanent, system defined and non-system. Okay, so segments also we can classify into like data segments are available, index segment, okay, index segment and rollback segment. Okay, so data segment means whenever we are creating a table, one data segment will be allocated. Okay, whenever you are creating a table, one data segment will be allocated. Whenever you are creating an index, one index segment will be allocated. Fine. Other than that, rollback. So whenever you are rollbacking the uncommitted transactions or so, this rollback segment gets allocated. So this is how it works. Fine. So next one we have the extent. So extent contains, we talk about like we won't be, since the blocks are in granular format, we won't be talking about extent. I mean blocks. Okay, blocks are the basic storage units we know already. So since we know that blocks are the basic, we don't talk as blocks, we talk about extents only, as extents only. Okay, set of blocks you call as extent. Fine. So extent management, there is a concept called extent management. What do you mean by this? First one is DMT. Okay. Second one is LMT. We'll see what these are. So DMT means dictionary management table spaces. Okay, dictionary managed table spaces. LMT means locally managed table spaces. So what do you mean by these? Okay, so dictionary managed table spaces means it was used like till Oracle 9.9. Okay, till Oracle 9.9 we were using this DMT table spaces as the default. Means your table space will contain the header. Okay, see you have your table space. Fine. So you it contains the header. Okay, so this is the table space you consider. And so for example, TBS1. Okay, TBS1. So this table space TBS1, it contains the header like this. Okay, so this is called as header, means what? Metadata. Fine, metadata of this table space. Metadata means what? Like how many extents are here, totally how many extents are available, and each extent is of how much size. First extent is of how much size, second extent is of how much size, how many extents are free, how many extents are used, like this. This is what is the metadata. Fine, so metadata of the TBS1 is kept under its own data file header. You call that as the locally managed table spaces. Okay, so I'll repeat. See, locally managed table spaces means its metadata is contained in its own header. Okay, own table space header. Dictionary managed table space means here this is my TBS1. Okay, so see, you have your system table space here. Here my TBS1 is here. Okay, so this is my system table space and this is my TBS1. So this is my user defined, my own table space. This is the system table space. So earlier, in case of your till Oracle 9i, it had its own header, isn't it? System table space had its own header. But what we had to do is, in dictionary managed table space, all about this table space, that is non-system table space metadata, also used to reside under this system table space only. Okay, like how many extents are free in the TBS1, how many used extents are there in the TBS1. So all such metadata will be present inside the system table space only. So whenever we are inserting some records or deleting or any DML operations we are doing, everything it has to go and check here in the system table space about this TBS1, then only it can do the DML operations here. Fine, so this is how it happened. So what were the disadvantages of this DMT? Means IO contention was more. Okay, IO contention was more. So every time it has to go and check now before doing any DML operations, it had to go and check in the system table space, like what are all the metadata, any extents are free, how much percentage used, how much percentage free. So all the details about this was handled by the system table space. So it was a like a cumbersome task. Fine. So that is why from Oracle 10G it has been moved now. So from Oracle till Oracle 9i only we had this DMT. All the table spaces were of DMT type. So from Oracle 10G, okay, from Oracle 10G, from Oracle 10G onwards, this has been replaced with LMT nowadays. So means very easy to maintain because its own header is containing the data. So it's very easy to maintain the data. Fine. So that is what is happening here. Okay. So we'll see table spaces types, permanent, undo, and temporary. So permanent means the whole session or the transaction that table space will be available. Then undo. Undo means it will when we are rolling back a particular transaction, it goes and stored under the undo. Fine. As well as when we are selecting and viewing a particular table, then also from the undo table space only we used to select and view the records. Fine. So temporary means what? So temporary means, as we said earlier, for sorting and searching and joining operations, all those things are being done in the temporary table space. Fine. So next one is system sysocs. So system means it stores the data dictionary, and sysocs means for auxiliary applications like DBCA, NetCA, DBUA, all those things it has been used. Okay. So system table space we cannot rename, or we cannot drop the system table space, or we cannot take the table space offline and so on. Fine. So this is what is the system table space, but still system has an undo segment as well. Okay. And sysocs. So sysocs, as I said earlier, all your utilities are being stored under sysocs table space. So next one is non-system, that is user creating table space. It gives us the flexibility because we are maintaining it, and for the application data we are storing here. Fine. So it's very easy to enable the tuning, or that is static or dynamic data, or backup requirements, all those things. It's very easy for me to maintain my own database. So this is the command to create the table space. See, create table space name, then that path will give, then size, that's it. Fine. So we'll create a table space. So create table space name, data file, path, size. So how much size you want? Size like this. Just we can leave like this itself, or else you can add auto extend on. Next, size. Okay. So increment by how much size you want to increment. Then on next size, then just max size. Okay, max size, how much size you want to give. So this is how we used to create the table space. Okay, so we'll create a table space and check. Select name from $v table space. So we have these many table spaces. We'll check how many data files are there. So what is the location of the data file? So select name from $v data file. So we have the data files here. Fine. So I'll create table space tbs2 data file path. So I'll give this path tbs2.dbf. Then size, how much? 100 M. Next, 5 M. Auto extend on. Auto extend on. Okay. Auto extend on. Next, 5 M. Max size. If you want, you can specify the size, or else unlimited. Unlimited, if you give till the hard disk size, it will go. Okay. So table space is created. This is how we used to do. Fine. So here these are optional. Auto extend on, next 5M, max size, unlimited. All these are optional. Just you can give create table space tbs3 data file path size 100 that's it. So like this also we can give. So others are optional. Fine. So this is how we can create the table space. So if I want to see, select name from $data file. If I want to add, okay, to this table space, TBS3 has one data file called, with minimum one data file we have to create the table space. Okay. So on with this TBS3, I want to add one more data file, for example. So I can give alter tablespace add data file path. So tbs31.dbf size 100 So like this. I didn't give the specify the table space name, that's why it's throwing error. So alter tablespace tbs3 add data file path you should give. So tbs3 I have added one more data file. Now you check, select name from $data file. See, tbs3 and tbs31.dbf, two data files are there. Fine. So like this only we can check dba underscore data underscore files is there. So select file name. For each and every table space, if I want to check what all the data files are there, I can use this. See, select file name from db underscore data underscore files, where table space name is equal to tbs3. Okay, so two data files are there under the table space name called tbs3. Fine. So the same thing I can check for tbs2 as well. So like this I can check what all the data files are available. Fine. So this is how I used to check. Now we know what are all the data files available, what are all the table spaces available, everything. Now I want to resize a particular table space. Okay. So resize means what? I want to increase the size. Okay. Yeah, you can if the objects are there, then reducing the size is not possible, but increasing the size is possible. If it is empty, you can resize, means you can give the minimum size, less size also we can give. So alter table space tbs2 resize some 500 small file table space tbs2. So I can alter the data file. See, alter database data file path. So resize 200 So in the data file level we can do it. So for big file table space we can resize like this. So we'll talk about subsequently. We'll see now. See, this is how we have created the table space. Now LMT and DMT we have discussed, and here in case of your there is LMT, you have two options you can specify. See, in case of your LMT management, okay, you have two options to specify. That is, one is local, another one is auto allocate. So what do you mean by this? Local means every extent size I am giving. Extent size I am giving. So local 5M if I am giving, each extent will be of size 5M. Okay, so this is a local means. Auto allocate means we leave it to the system, we leave it to the server to allocate particular size. Okay, so for example, auto allocate, just I'll leave it like this. See, So extent management local. By default, this is the local management only nowadays. But uniform size. Here, auto allocate is the default one. Okay. So uniform, if you want to give uniform, every extent should be of this size only. If you want to give, then you can give like this, or else auto allocate only is a default. It will take automatically how much it will manage. Oracle server knows how to manage, like how many extents it can allocate. Initially how many extents it can allocate, each extent how much size it can allocate. So everything is left to the system nowadays. Fine. So I want to override it, means I can go for uniform size. Okay, so this is how it works. So next one, what are all the advantages of this LMT? So that is what we discuss now. Next one, segment space management. So what do you mean by this? Segment space management means like how to maintain the segments. Okay, so like how to maintain the blocks, all those things are done here. Okay, so extent management only we saw that, DMT and LMT. Next one is segment space management. Segment space management means either it can be manual or auto. So auto. Earlier, till Oracle 9.8 was manual, was the default one, and auto. Now it is auto. Auto means, what is the difference between these two? Manual means, as we said earlier, we have to give how many number of extents we have to decide. Okay, the initial extent should be how much size, how many number of extents should be allocated at the first, that is during the database creation, how many extents should have been created with the starting number of extents, and after that how many extents it should increment by. So all those things will be decided by the DB earlier, as well as PCT increase, PCT free, all those things. Same PCT increase, how much percentage PCT increase and PCT used. Okay, all these things we used to decide, minimum extents and initial extent, how much size. So these are things which we had to decide earlier. Now it has been replaced auto, as well as it is stored in the form of bits. Okay, so like which segment, like which is zeros and ones, it is replaced and maintained, so that which extent is free, which extent is being used, all those things are being maintained in the form of bits in auto mode, so that it is very easy for the management. Fine. So that is what is called here. And manual means you have the, like how many extents, all these things I said, no. So these you call it as free list and free list groups. Okay, free list and free list groups. Okay, so earlier we used to maintain our segments like this, free list and free list groups, but nowadays in the form of bits we are maintaining, so it's very easy and handy for maintaining the whole segment space. Okay, so this is what it happens. Fine. So so dictionary management, as I said earlier, we used to give like this. If the extent management is dictionary, you have to give default storage, how much, initial, how many extents, that is 1M. First extent will have 1M, next extent will have 1M size. Okay, 1 MB size. Then how much increase, how much increment it should be. So like this, we had some formula and we had to evaluate all those things we used to do earlier. But nowadays, this is being replaced by just extent management is local nowadays. In the local, we can give either auto allocate or auto allocate by default, or else you can give here like this, local we saw, no. So how much uniform, that is uniform and auto allocate, right? So auto allocate is the default. We can give uniform as well if you want uniform size. So each extent will be of this size only, so that I can override. Fine. If it is local extent management, I can give either uniform or auto allocate, but auto allocate is a default one which is being maintained by the Oracle server. So uniform means instead of that auto allocate, I want to override, I want to maintain the extent management, means I can give uniform here. Fine. So this is the LMT and DMT differences. So next one is undo tablespace. So undo segments is stored here. Then extents are as usual locally managed only. Like this we used to create. So we'll check here. See, show parameter undo. So undo tablespace is this one. Undo retention. Undo retention means these transactions, undo transactions, these 900 seconds, that is 15 minutes, it can be stored under this undo tablespace. So unless and otherwise the new transactions are coming and overwriting, it will be there. Fine. So till 15 minutes it can be there, but new transactions didn't come in, still that it will be there. So now the undo tablespace is being filled with new transactions. It doesn't have any other space, means it will start overwriting this already old uncommitted transaction records. Fine. So that is what is undo retention here, and undo management is auto. So earlier manual was the default, now it has been replaced with auto. And temporary undo enabled. So this is the new feature of Oracle 12c. Okay. So this we'll see in the subsequent chapters. So now we know that undo TBS1 is the undo tablespace. So what I want to do is, now I want to change this undo tablespace from undo TBS1. I want to change this to undo TBS2 or so. Fine. So what I'll do, I'll just select name from $data file. Okay. So I'll select one path. So till here. So I'll create one undo tablespace. Undo TBS. Create undo tablespace. Tablespace name we should give undo TBS2 data file path. So undo TBS2 .dbf size 100 auto extend on. So 100 So now we have created undo tablespace. Fine. So now what we'll do, I want to make this undo TBS2 as my default undo tablespace, and the earlier undo tablespace I want to remove it. Okay, I want to drop that tablespace. So now I'll give alter system set undo underscore tablespace is equal to undo TBS2. Okay. So now you see show parameter undo. So now undo TBS2, it has changed. Okay, my default undo tablespace is now undo TBS2. So this is it works. Fine. So similarly, now we know how to create one tablespace and how to add one data file to it and how to resize one data file, isn't it? There is alter database, data file path, resize pk. And also auto extend on we know. So there is one interview question like how you will increase the size of the tablespace. Means either I will add one more data file to it, or else I will increase the data file size, or else I will give auto extend on. So these are the three options. Fine. So this is how it works. See, how to increase table space size means one is auto extend on, number 2 add data file, number 3 resize. So this is how it works. Fine. So this is how we increase the table space size. Okay, so these three things you should know. Fine. So next one is we want to drop the table space. Okay, drop table space means how will you drop? So what you can do is drop table space. You have two options here. One is including contents, you can give including contents, or else including, okay, so including contents or including contents and data files So these are the two options you can do. So normally how you will do is drop tablespace name, including contents and data files. So this is how we used to give. So if you are giving including contents means in OS level data files will be there. Okay, in OS level data files will be there. Data files are there. Okay, in OS level. But if you are giving contents and data files, both, that is in OS level as well as Oracle level, it's getting removed. Okay, Oracle level, it's removed. So this is how it has been designed. Okay, this command. Fine. So now if I want to I can drop, I can add. If I want to make my table space, so no, by default it will be in read write only. Okay, if I want to make the table space read only, you can make like this. See, alter tablespace name, offline or read only. Okay, or read write you can give. So read write is nothing but online only. Okay, so we can check here. See, I want to select name from $v tablespace. Okay, name from $v tablespace. I have these three, isn't it? TBS 1, 2 and 3 I have created. So I want to drop one. So drop. So drop tablespace TBS 3 including contents and data files. Contents and simply I'll give contents. Let's check what happens. So I have dropped. Now select name from $v tablespace. See, TBS3 is not there, but still I'll go to my OS level. Yeah. So under DB2, I'll check data file. See, TBS3.dbf, TBS3 only I dropped, isn't it? But in the here in the Oracle level it is dropped, but in the OS level these are there. Okay. TBS3 and TBS3 dot there. So we have to go manually and remove it. Okay, TBS3 star dot dbl like this. So to avoid this only, we can give, if we don't want, if we don't want the data files, just we can give as it is. Or else what you can do here is, I want to drop the table space, drop table space TBS2 including contents and data files. So now I'll check, select name from v dollar tablespace, from v dollar tablespace. See, TBS2 is not there. I'll go check under, see, TBS2 here also it's not there. Fine. So this is what is contents and data files command. The use of contents and data files command. So earlier here tbs2.dbf was there, but now since I have dropped the data file, it is not there. Fine. So this is how we used to do. Fine. So now regarding this temporary table space. Okay. So create temporary table space, temp2, temp file, path, any path you can give. So temp2.temp, any .dbf also you can give as the extension, but for our identification we are giving here. Okay, .tmp size 100m. So now we have made temp2 as the default. I mean, we have created one more temporary table space, but temp1 only is the one. Okay, so we can check here. I want to check here. See, alter. I want to make this as the temp2 as the temporary table space. So alter database default temporary table space, default temporary table space, TBS, I mean temp2. Okay. So now our temporary table space is here. So you can check database underscore properties one. Here you can go and check. Okay. So default temp table space, select property value from database underscore properties, where property name is equal to default temp table space. See, temp2. So earlier it was temp1, now it has been replaced with temp2. So like this we can change the undo table space as well as the temporary table space as well. Fine. So if you want to make a table space offline, online and all, we'll check now. So describe db underscore tablespaces. So select tablespace name, comma, status from db underscore tablespaces. Okay, so everything is online. So we'll make one tablespace offline, tablespace users offline. Okay, so now we can check, select tablespace name, comma, status from db underscore tablespaces. See, it has become offline. Users have become offline. So we won't be able to create the objects, or we won't be able to access any objects inside the users table space. Okay. So if we want, we have to make it online. We can make it. So alter table space users online. So this is what we used to do. Select table space name, comma status from db underscore tablespaces. So it has become online. Fine. So whenever it is in read write mode, it will show you as online. So I'll make this as read only. See, it has become read only. Now if I want to make it read write, just make it read write, it will show you as online. Alter table space users read write. So now you select it and save it. See, it has become online. So this is how we used to do. So, and all these whatever we have discussed till now are simply small file table spaces. Okay. So big file, what do you mean by big file table spaces are there? Big file table spaces. So for storing objects like LOBs, okay, large objects, videos, images, logs, okay, for all such things we are using big file table spaces. Okay, minimum 1 GB we have to give for this big file table spaces, and maximum like it depends, normally like 5 to 6 table spaces. Normally by default, in normal scenarios it will be like 5 to 6 big file table spaces only. Okay, so if you want, you can resize as I give earlier. Alter table space, for example big file table space, resize some 5 GB if I am giving, it will get resized as usual. Only the other views, everything we can use as usual, but while you are creating the table space, you have to give create big file table space, you have to give. Okay, big file table space. Other thing, data file path, everything is same. Data file path size. Okay, like this. So now we'll see. So create big file table space. So same BGTBS. So as usual, normally just you give big file, that's it. So it starts from 1 GB, and as usual you can add the data file, you can resize it. So alter table space BGTBS resize 5G. So it depends how many data files. For example, 5 data files are there, means it might distribute the space among it. It will arrange automatically how much space has to be given among the data files, but it doesn't happen in case of your small file table spaces. So there we have to give, we can resize in the data file level. Fine. So that's the difference between big file and this one. So like this we can add and do it. So this is how we have here, and similarly here we saw undo table space and temporary, how to make a temporary table space. That is, this is how we have to make a temporary table space. Okay, so I'll share you the document. You can verify, we can very well go through it. Fine. So fine guys, we have seen table spaces today, and in the next class we'll see the subsequent chapters.